In the last video, I gave you very basic introduction of the statistics, and we said that statistics is the study of population data by using the sample data, because the collection of the population data is hard and takes longer time. So we pick samples that represents the population, and then we study that sample and we draw a conclusion from the sample, and then we apply that conclusion to the whole population. Okay, now if you want to study the population by taking the sample, then what are the ways, what are the techniques to collect the sample data is the next thing that we talk in this video. Also, we will talk about after we collect the sample data, how do we write them in a nice looking format, in a nice table form. Okay, that's the next thing we will be talking in this video. All right, so in order to eliminate the bias, statisticians use 4 basic methods of sampling that are designed to ensure that each member of population has an equal probability of being selected for the sample. Number 1 is the random sampling. Okay, a random sample is a sample in which each member of the population has an equal probability of being selected. The method is, so suppose I want to pick 3 students from my class that has 50 students. I want to collect a sample of 3 students. Okay, so if I look at the student and pick the student, then I might be biased. I may be selecting taller students only, or shorter students only, or specific type of students only. So to avoid that bias, what I need to do is I need to use the random sampling. For the random sampling, what we do is we assign numbers to each student, but the person who select the sample does not know which student had what number. Okay, assign the number to each subject and pick numbers randomly. In this way, all subjects have equal chance of selecting. All right, that is called the random sample. Another is called systemic sampling, that is obtained sample by selecting kth member of the population, meaning you assign the number to each subject or each individual of the population. Okay, and then you pick like 5th, 10th, 15th, 20th, like those numbers only. That is called systemic. All right, so for example, to select a sample of 40 out of 200, we select every 5th. However, the first is selected randomly between 1 and 5. The second is selected randomly between 6 and 10, and so on. That is called the systemic sampling. Another is stratified. The population is divided into subgroups. Okay, for example, in the class picking 3 students example, I can divide the students like boys and girls 2 groups, and then pick 2 from girls and 1 from boy, or 1 from girls and 2 from boy, and so on. Okay, in that way you will be selecting both gender. Otherwise, if you pick just 3 students by picking 3 numbers randomly, then they may be all the boys or all the girls, like that. Okay, so to avoid that, you can divide the whole population into the groups we call strata. Okay, according to some characteristic, like from gender or eye color or whatever you want to know. Okay, you want to select, you want to divide, and then subjects are selected from each group. All right, next is the cluster sampling. Population is divided into clusters or sections, and select 1 or more clusters using all members from that cluster. Okay, you divide the population into several groups, and each of the group must have all types of population, all types of sample in that cluster, and select everybody from that cluster. That is called the cluster sampling. And multi-stage is population is divided into clusters, and pick some cluster, then selected cluster are divided into cluster again, and randomly select the subject. So this type of multi-stage sampling is used if this population is very, very, very big. Okay, so for example, the whole United States population is big, right? So you can divide into states, and inside the states you can go into the county, and inside the county you can go into a street and then select the population from that street. That is the multi-stage. You cluster and recluster again and again into several stages. All right. So these are the very basic methods of collecting samples from the population. All right. So I'm going to discuss very briefly about the errors and types while collecting the sample. Sampling error is the difference between the results obtained from a sample and the results obtained from the population from which the sample was selected. Okay. So for example, if you are collecting a sample, that sample may not represent the entire population. Okay. And if you are finding the average height of the student in a class, if you are measuring the height of each student, like the whole population, and then measure the height and find the average, and if you collect a sample of 10 and then find the height of that the 10 people, that height may not be the same, the average height may not be the same. Okay, that is called the sampling error, because the sample was not very much like the all population, meaning it is not representative to all population. Okay, that is called the sampling error. And a non-sampling error occurs when the data are obtained erroneously or the sample is biased, or non-representative sample, such as scaling error, recording error. So if you are collecting a sample, if you make a mistake collecting the sample, that is called non-sampling error. If you made a mistake recording the data, that is called the non-sampling error. All right, that's the very basic introduction of chapter 1. The next thing, so now you know how to collect the data, right? We learned different techniques to collect the data. The next thing is, after you collect the data, you put them in a nice table so that you can tell many things about the data after you put in the nice table. All right, that is called organizing the data. Okay, so when the data is collected randomly, they look like this, right? They look like this. Look at this. They look like this. So these are the 25 army inductees were given a blood test to determine their blood type. So the first person got blood type A, second has blood type B, and then B, the third has A, B, and O, and so on. So from this data only, this is called the raw data. Okay, we call this as raw data. So you cannot say much about the data here. Okay, so what we want to do is we want to plot these, we want to put these in a nice table so that you can see many things. So putting the data, the raw data, into the nice table is called organizing the data, or organization of the data. Okay, now, so since there are two main categories of the data, one is the qualitative data or the categorical data. Qualitative or categorical. It is also called qualitative or categorical data. So qualitative or categorical data are non-numeric data or non-rankable data. Okay, for example, the color or the race or ethnicity or religions or blood group type, the favorite colors, all those kind of data are qualitative data or categorical data. Okay, so on this type of data, to make a table, nice table, what we do is we make basically 1, 2, 3, 4 columns in a table. Okay, on the first column you write the different categories. So what are the different types of letter used here? A, B, AB, and O, right? That's what you write. These are the class A or category A, category B. You list all the different category on the first column. Okay, on the tally, what you do is you count how many. For example, A, how many A are here? 1. How many A? 2, 3, 4, and then 5, right? There are 5 A's. If you cross each data, then you will know how many are there. I mean, you will not miss any if you cross each of them. So how do I write the tally? You write 1, 2, 3, 4, and then 5. So we make a block of 5. Okay, that's the tally we call tally. But once you know how to do that, you don't need to write the separate column for tally. Okay, now how many B category are there? So 1, 2, 3, 4, 5, 6, and then let me see one more there. So 1, 2, 3, 4, 5, 6, and then 7, right? So there are 7 people with blood group B. So how do I write that? 1, 2, 3, 4, 5. This is block of 5, and then 1, 2. That is 7. Okay. So the frequency is how many times that value repeated, or how many tally marks are there, right? That's the frequency. You count and then write the number. Okay. And how many O are there? If you count like that, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1, 2, 3, 4, 5, and then 1, 2, 3, 4. That is 9 total. Okay. And then AB are 4. 1, 2, 3, 4. If you count, you will get 4 there. All right. So the frequencies are how many times a particular value is repeated. Okay, now how do I find out the percentage? To find out the percentage, what you do is you write down frequency divided by the total frequency times 100%. 100%. Okay, for example, if you want to find out the frequency of category A, then you do 5 over 25, 5 over 25 times 100%, right? If you do that, you divide both top and bottom by 5, you get 5. So 100 over 5 is 20%, right? So 20%. So this is what we get here. Similarly, for this one, you get 7 over 25 times 100%. 9 over 25 times 100% will be 36. 4 over 25 times 100% will be 16. This is how you find out the percentage. You see that? This is what you did, and then got the 28%. So this is how we make a table for categorical data. On the first column, you write class, and you list all the different categories. On the second column is the tally, and the third column is the frequency, meaning you count how many of each category are repeated in the data. And number D is the percentage. You do frequency over the total times the 100%. All right, so this is how we tabulate. We make a table we organize the data for categorical data. Thank you, guys.